Does anything? That's super weird though. Gosh dang it. Let's see if I can get a link. Hey, Jenny Head.
Ms. Hyde.
Wow, it's quiet here today.
I'm gonna send a new invite to you guys and see if that shows up. Oh, how are you?
I see you. I see you.
Oh, good.
And this
Hey,
is
AirPods.
the old one. Which makes me think I'm seeing it. Now, should this show up somewhere on your page?
Eventually it'll show up. Hmm.
So are we joining in today?
So you see that?
I saw a hangout a second ago.
Hey. Sound guy. Probably turn my sound off. Is that what you were going to say?
There.
That's awesome.
Nice. Sorry. So yeah, can I use your computer then for the lecture notes?
You don't want one that drops out every 15 minutes or so?
Okay.
You know, it's simply off.
Sure. So, what do you want me to?
So if you could download the lecture notes, this email.
So I'm going to get out of this hangout then, if that's cool with you.
Okay. I got this email. Oh,
Yeah,
this is.
okay.
You can use mine if you want. Yeah.
No, I'll take it. Oh, okay. No, I did it wrong.
Doesn't really matter if it's
Oh.
recording or not. Everybody shows up.
So you have your own folder. It's the CS5 Chatham course.
For a number of people, looks like Jessie is going to be doing like a road trip for a couple weeks, and so she's not going to continue the course.
She was took a road trip.
Yeah, just be traveling and grading that.
And this is called, what's the title of these?
Section 3. So,
That was the surprise me.
yeah.
It's still coffee.
Where is she right now? She's one of our remote folks, right?
Yeah. She was in grad school. She was a former student of mine. I know her shenanigans.
Oh.
Real quick.
Okay, so do you want, oh, well, there they are.
Yeah.
You can play with the rest. Great, thank you.
Did you have any luck on the homework?
I didn't even do the homework, which I feel a little terrible about, but I'm totally up for teaming up and getting together with anybody to do homework.
That's as far as.
Yeah.
It's fairly long.
We should maybe just schedule.
It probably has enough battery.
I know, like, the lab.
Because I don't know, I missed the lab last time. I just
It was just her time.
I don't even know what happened or when. Yeah.
Yeah, so we did like some really like specific troubleshooting because it was just the two of us, so it was kind of like all our
Oh,
questions and just setting stuff up. And cool. I'm really proud that I got the pickleball, but
Ashton's home. So I should give you his phone number.
Yeah, or email or something, or Facebook.
That's
I'm weird on the phone. I guess I could text him. But
You can text him. That'll work very
Cool.
good. He's very text responsive.
I don't know when. I don't know if I'd be up for taking lessons right now, just because I have this going on and.
Well,
and
there's
stuff.
his number.
Let me grab that. I'll throw it in. Yeah, because this is like.
Okay, I haven't told him about it yet. I told Marco. He just got it.
Hey,
Hi.
how's it going?
Rockets.
Oh, very
Good. How
5 on.
Oh, we're doing pretty well. I don't know. Jenny says hi.
Hi.
Hi guys.
He goes by Ashton Madison. Or Ash. He is teaching lessons. He is extremely flexible, except for the fact that he's going to want you to come to his house.
Oh, yeah, of course.
He's currently got a DUI and no driver's license.
Oh,
That's how I usually force the teachers as you go to their place, yeah.
Oh, I got in trouble.
Yeah, fortunately, he's a pretty good boy. It's like, he's turning as minimal a DUI. We've already downgraded his charges, and he's only got 3. It's still costing thousands of dollars.
Scores have taught us that it's not a doesn't prevent a successful professional career. Yeah. So.
Well, he's at our house.
Okay.
Yeah.
It's 1111 West 9th.
Oh, great.
So.
It's right around the corner from our house.
That t-shirt is it's making me want to floss right now.
I think it's a trail mix that I ate for class.
Sweet. All right, completely unrelated to flossing. Welcome back to class, everybody. Yeah, so this week, as I sent in the email, this is a big week. We are talking about data and functions. Today's mostly about data, with a little bit about functions, and then next, coming Wednesday is about functions and starting to get into recursion, which starts getting really exciting.
Starting to get what? What was the word you said?
Recursion starts to get exciting.
Oh, it's like
so-
the echo.
Yeah. So, yeah, it's going to be something that's basically just gets me, so you won't see the rest of the class, but that way I can, like, talk to these guys, and they can kind of see you up on the screen that's behind us.
That's fine. Oh, great.
Yeah, it'll be a little less awkward when you guys can all hear me when I actually, because I'll actually talk to the microphone like all the time, which would be nice. Gosh, I look so white.
Any slides?
Oh yeah, and so once I pull up the slides, I'll be putting slides on the screen share like this.
Oh, there we go.
You'll be able to see them. But yeah, I just want to kind of introduce what we'll be going over today. Mostly we'll be talking about data, which is kind of one of these slides. I think it's next week. Kind of talks about computer science is really about data and doing stuff with data. So it's about, we kind of touched on this in the first lecture, but it really is just kind of about, okay, like we have information from somewhere, or we're generating information, and we want to manipulate that and spit it back out in some sort of way, whether it's analyzing it, whether it's, making it prettier, whether it's, glitching it all out. Yeah, that's basically what programming is, at least. So we're going to be, go ahead and get into it. These are the slides. First, we're going to talk a little bit about the command line. You'll also hear this called the shell environment, like Bash or C shell or Z shell. There are a couple of different things. Or on Windows, it's just like command line. Or I think they might have it in new Windows, like Windows 10.
That's what you've got there.
Yeah, you may have PowerShell.
Yeah.
And maybe a pen.
Yeah, so Windows 10 comes pre-installed with PowerShell, which is a similar to Bash or I'll actually pull it up. We'll go ahead and screen share the whole desktop on this one. Oh, gosh. So as you can see the whole screen, this is PowerShell, which is Like, so the Windows command line, if you just hit like run cmd, or kind of looks like the old DOS screen. Like, it works, you can do stuff, but PowerShell is a little bit more powerful. It supports different things. Like in Windows, you can dir and you should get the current directory. Or I guess PowerShell.
Get to
So is
that.
this terminal?
Yeah, it's a Windows version of terminal. So on Windows, if you hit the Windows key and you type in PowerShell, you'll get PowerShell. And PowerShell supports a lot of the Linux style commands. So like, if you look at some of the labs they have, go into like your terminal and do these things. Go ahead and use PowerShell. Like ls will list all the stuff that's in the file. Space ... gets you back a directory. C space.
So to get here, we just key and hit
PowerShell. Yeah.
And then we're into the command window thing.
Yeah, a lot of
Thing
the.
that it was dancing around online.
Yeah. So I'll let you do some stuff. If you get deeper into programming, especially if you wind up doing anything with like Raspberry Pi, actually they just switched away from the command shell, so that's nice. But with a lot of programming, they'll start having you use the shell. Oh, come on, just screen share. To mess around with stuff instead of like a graphical environment. And so eventually, like learning some shell commands might be handy. Like especially you, Whitney. Like if you start working with like more database stuff, you might wind up having to like access some like Linux backend type things. That's mostly you'll be working with a command shell. But we kind of bring that up. It's got its own little language to it. Kind of programming as learning a foreign language. Like it's going to take practice. You don't need to know it all, fortunately. The secret to computer use and programming in general is Google. Like anytime you see an error message pop up, throw it into Google. Like somebody else has run into it before.
I find that to be.
Yeah.
But so that's the way that, okay, I guess I tend to think in terms of glossary, the dictionary, a proprietary thing rather than, so, and I know I can find something on Google, but then, I guess I always find myself looking for the one that's a regular, that's a steady source. But you're saying, don't worry about that, just wing it.
Yeah, and well, I mean, ironically, in terms of like steady sources, like the secret weapon that you'll use, Stack Overflow, and basically, if you search any computer error, you'll wind up getting to this site 9 times out of 10, anyways. I'll screen share it
Stack Overflow. I think I ran
screen share it
into
real quick. But Stack Overflow. Go back here. Basically, a question and answer site for questions. So you might, be like, let's search for super common. But a bunch of people have run into, when I call this activity, somebody had a problem, had a bunch of code that they had written, and they're like, hey, I'm trying to do this, and I'm getting a null pointer exception. Like, why is this happening? And somebody has an answer here, like, hey, try doing this here. So, definitely.
One of the weird things that I had happen is I had an error, and it was telling me it was on line 16 Python when I was writing the 4x4s. And the error actually was in line 15, and I had an extra bracket, but because it was an extra parenthesis,
Sure.
it said that the parenthesis then, as far as it was concerned, that was missing was in line 16, except you'd look at line 16 and you couldn't find the error.
Yeah. So I don't know if you were unable to hear that. Kurt was mentioning he had an error where it said, Python said, hey, error on line 16, but it was actually on line 15 where he had an unclosed Sometimes that's going to happen. The compiler or the interpreter is only going to figure out to the best of its ability where the error is, what's wrong. That's a pretty common thing. Like if you have something that like needs an end terminating block, like a bracket or a parenthesis or a quote or something, it'll like keep going to the next line and try to find that. And when it goes to the next line and finds something that doesn't really work with that, it'll be like, oh, here's where I stopped, and so here's like where to start looking for the error. But yeah, so Stack Overflow. When you Google something programming related, you'll probably get to Stack Overflow. It's a wonderful, wonderful site. It will be your friend. Absolutely.
I feel like if I had the skill, I'd be fun to do that.
Yeah. So, but kind of similar to Python. Like Python, you've actually been kind of exposed to this if you've been running the interactive mode with like the 3 carets, the greater than signs. So like your computer has a command line that you can navigate through folders and create folders or run things directly from like the text, like by typing in Python or Python homework1 problem1.py would actually like run that Python file that you wrote. Similarly, like Python actually has that interactive mode where you're kind of like running through the things, and it's kind of the same concept.
But we're not worried about that a ton right now, right?
Yeah, or we're not worried about that a ton because of Cloud9. But like in the Cloud9, there is like there is a shell. It'll have like a bash at the top. So like if you want to run like interactive Python on that, you can type in the shell. You can type in Python, and it'll start up like a little Python console. That would let you like load up Cloud9 actually really quick.
It's open somewhere already.
I think I might have missed what bash is.
It's just the name of a shell. So that's like the command line. So
Command line is the name of one shell.
Yeah. So terminal, bash, they're all like command line shells. Back to the born again shell. But yeah, so over here back in Cloud9, you'll see this. We've got this bash thing, and so it's like the command line. So we can go like ls. So ls is like whatever is in that current directory, and it kind of shows like, hey, this current folder that we've got. It's actually like the CS5 workups folder. We have the graphical representation here, and then it's got like the just text thing right here. But we could actually run commands from it. So we could go Python hw0pr1.py, and that would run this program that Kurt wrote here.
And it looks like you've wrote this.
So there's a $sign here. That's just like the prompt. So it tells you like, okay, we're currently. So like every line that I start just automatically just has that, like that's like that, like a colon or a caret or whatever. Like you can't. Hitting backspace, but it doesn't like clear it out. So it kind of tells you the user and like kind of the current like directory structure that we're in, and then like a little caret to say, okay, like this is like text, and this is like where we can type stuff in from. So just type stuff in. But hey, command not found. Yeah, so this is this bash shell is like a command prompt that you can use live within Cloud9. And from
so then there are all kinds of programming rules, like regarding rules for Python. Is a whole different set of programming rules that apply to bash.
Yep. So you can program in bash and create. They're called shell scripts. You might Google it later. It comes in handy, like say if you had a directory with 1,000 files, 1,000 photos, and you wanted to rename them all to be like, add the word, Jenny's photo, colon, the file name or whatever. You could write a shell script that would go through that directory and rename every file all at once. To make your life, but it can like say, if you have 1,000 files to rename, can make life way easier.
It's sort of like the find and replace function
Yeah.
around in various
Yeah.
things.
So, but also importantly from this shell here, if you type in Python, we'll open up the Python interpreter, and then you can just try out little like pieces of code, and it'll just execute it immediately without having to write it in this. Instead of writing it in a separate file and then hitting run, you can just run it right here.
Makes sense if you are a speaker of Python, but if you're not, using the window and then run, going back and forth, it's slower, may not be easy.
Yeah, it may or may not be easier. This is kind of useful to just like test out like 2 lines of something. You know, if like I forget how to, is it, what, I want to do some simple math. I need to know what 58 divided by 6 is. I can do 58 divided by 6. Or if I'm trying to figure out, is this like the right syntax or something? Oh, I'm not getting an error versus like. It's a quick way to kind of check to see if like commands are valid. So.
Can we do the thing to make the screen image larger?
I don't think it's going to make this any bigger, unfortunately.
This, or is it?
Yeah. So I can zoom in on this here. There we go.
So why would we be coding in there?
This is be like if you wanted to like practice or like just evaluate stuff or test stuff quickly.
So I know that I was
Opening
doing
up a
it
new
in the
file.
Python thing, but if you started being able to think through the 4-bys, you could stick a 4-by right in there.
Yeah, you could like.
And see what its result would be.
Okay.
And then you could say, oh, that one works, and then type it formally into the line on the program.
So manually using
Right.
Yeah.
Brilliant.
Well,
Okay.
all right.
Cool.
See, I was typing up
Cool.
pseudo lines on the bottom, and in testing, when I got a good one, then I would copy paste it back into my code.
Yeah.
At least we will test.
So that's just kind of some
So
basic
there,
stuff.
you can see for 4. I got enough factorials and the square roots.
Dang, good for you. I didn't use any of those.
Nice.
Oh, I looked at yours briefly and I went, oh, those are really simple. And then I decided I better stop looking.
Nice. All right, so we will get back to. This is kind of a little like sidebar on kind of the shell. That it works as there is some like programming involved, but yeah, we'll go ahead and get to the meat of today's lesson now. We're going to be talking about data, which is, I don't know, kind of boring, kind of exciting. The amount of data that we're producing is exponential right now. I mean, everything's getting recorded, everything's getting stored. As of 2002, globally we were producing 5 exabytes, which is basically 1 million terabytes. We moved to now 2015, where we are, over 1,000 times more than that right now every year, and it's just every year, looks like it's basically doubling every. Probably close to every year or two. So I mean, the amount of footage. I mean, I think something like every hour, like 26 years of content get posted to YouTube.
Is it awesome? I'm just curious.
Yeah, I mean.
I think it's.
Yeah, well, I mean, just as like storage has gotten super cheap, just like recording more things and holding on to more things has just become much more practical. But yeah, and so kind of.
How much is a zettabyte?
So a zettabyte would be 1 billion, I think. 1 billion terabytes. Oh yeah. It's like like, so currently, if every human being on Earth had a 1 terabyte hard drive, like, we would fill them up before the end of the year. Just the data. So, but what we have to. So, as computer scientists, like, data is data is something that we're going to be working on working with, and we're going to figure out how to use that. So there are a couple of slides here that I'm going to skip past to just about like big data. If any of you guys are curious about like what that means, we can go into it kind of after the slides. It's pretty irrelevant to what we're talking about
Now,
right
is
now.
most of that data, I mean, okay, I've got some data, and it's sort of behind some passwords.
Mm-hmm.
So it's not, I mean, anybody that was good at hacking could probably get at any data that I have.
I don't know.
Okay.
Pass.
Most of this huge amount of data is not accessible, though. Is that true?
So the question is, like, how accessible is this data? Is it password protected? Is it, the world is moving to more and more open data. A big part of web programming is like using data that's available that other companies offer, sometimes that they sell. But yeah, and a big thing that we're going to be kind of concerned with is like how do machines like read and interpret data, because at the end of the day, it's all just big sequences of ones and zeros. How do we actually make sense of that? A lot of the big data is really related to is like, okay, you have just this big pile of data. What's in there? Like, how can we interpret it? How can we actually like make insights out of that massive amount of like seemingly nonsense?
But we could also take that as a massive amount, for example, like 2x4s, and start hacking and slashing it potentially and making it into some other kind of visual or audio event that becomes potentially it moves, even if it's like a wind-up, and then and one could start to mess with using big data to drive artwork.
Oh yeah. So big data and artwork is a super interesting combination. Especially there is a lot of like data streams out there for free that will just pump out a bunch of data into the world. And so as artists, there are a lot of really interesting topics with kind of the use of data, and kind of comes down to with computer sciences, about taking data and interpreting it and doing stuff with it. That includes messing around with it in an artistic sense. But on a fundamental level, we have to start talking about like how we actually like use data. And the first big concept is that data has types. And the most fundamental type of data in a computer tends to be the integer. Are you guys all familiar with integers as opposed to fractions and stuff? So integers are like whole numbers. So anything from negative whatever to positive whatever, but no fraction. No fractions. So 1, 2, 3, 4, 5, nothing in between 1 and 2. That'll become important in a little bit, but yeah. So the other thing is that while the numbers in a mathematical sense are infinite, like computers have to store data in like physical addressable memory space, and it figures out a certain amount of actual memory to give to each number. So an integer can store any number. The way Python stores them, you can store any number from negative 2 billion to positive 2 billion or so, 2.14748 whatever billion. It's usually not a problem, but occasionally you'll see things where, like, if you ever see a program where it like goes from a really high number and immediately jumps down to a really low number, like a negative number, that's because the odds are is because it was like adding stuff onto that number, and it ran out of room. And so all of a sudden it went from 2 billion, immediately jumped back down to negative 2 billion, because like that's the range in which like an integer can fit into, like here in Python. Similarly, like you'll see that happen with like 256 in like old arcade games and stuff. Things will jump from 256 to 0, or from 127, or from positive 120, positive 127 down to negative 128 and back up. That's something you may see in terms of things like color spaces. Like you have an RGB slider that goes from like 0 to 255 on each color channel. And that's because, so 0 to 255, that fits into 8 bits or 1 byte of memory. And so once you fill up that number, fill up all 8 bits, that's equal to 255. If you add 1 to it, that number like clicks back down to 0. It's like, if you're like counting in base 10 with only 2 digits, so like you had like a space for a number here and a space for a number here, and you go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 7, 9, 20, right? But then once you hit 99 on the 2 digits, you went up to 100, like that 3rd digit that you need, if you didn't have that, like the number would just like cycle over to 0. Kind of like,
Look what happened with Y2K.
Yeah, that's exactly what happened with Y2K. That you had a bunch of computer systems that were built back when memory was super expensive, and so they just stored the year as a 2-digit number. So it was fine when it was 1978, when it was 1985, and as soon as it was like 1996, people were like, huh, what's going to happen when the computer thinks that it's 1900?
So total digression, so we can talk about this. Nothing happened. It seemed as though nothing happened.
There were some things that happened. They tended to be pretty minor, and people spent a lot of time and money like finding code that was going to screw up and fixing it. That kind of raises the question, like, what happens if you need more? What if you need more than 2 billion of something? Well, you can get a bigger number, a number that takes up a bigger footprint in memory. In Python, we have the long data type. It still has a finite limit, but it's way, way bigger. Probably to like kind of like nonsense number bigger. Like the odds of you running out on a long are pretty limited. Kind of tangent. If you need to go beyond a long, there are libraries where people have written that like let you have even bigger numbers. You probably won't ever hit that, but you will very often use floats. Sometimes also you'll see double, and that's just like, so floats are a very old kind of data structure or way to store numbers, and it's called floating point because it stores basically 2 numbers, or it stores a big number and a location of a decimal point along that number. So if you want fractions, or if you want to divide things evenly, like I'm going to take 2 and divide it by 3, you'll need a float to get because you'll want to get like that answer to be like 0.66. So occasionally you'll see the word double, and that's just like a float that's been given like a bigger footprint in memory, so it's called double because it's double precision. It's twice as big of a memory footprint as a float is, and so it can store twice as many numbers after the decimal place.
Did the program ever do the roundoff?
The program will never round. Well, that's not totally true. Floats have a certain limit of precision, and so eventually, probably with a float, it's probably after 7 or 8 or 20 characters or something. You have quite a bit before it says, okay, like this is as precise as I get. So there is a precision limit. It's probably never going to be relevant. Like if it's relevant, you'll probably wind up doing something like you'll have a special. again, you'd probably want to look for a number library that would be devoted to being like very.
And if you're doing that, you probably wouldn't.
You'd probably use Python. Might be something to use. Python's actually pretty common in scientific computing. Just pick up. And finally, we have Booleans. I don't. Finally is a little bit of a misnomer, but we'll definitely run into Booleans a lot. Rather than storing, 2 billion, 4 billion, a million billion numbers, they just store true or false, or a 1 or a 0. You'll get these like anytime you do a compare operation, like an equals equals or a point, exclamation point equals, or greater than, less than. It's actually a function that returns like a true or a false. Like 5 is equal to 5, true. 10 is equal to 8, false. And they'll wind up mapping to 1 and 0, 1 for true, 0 for false. There's a thing in one of these later slides that alludes to that. You probably should never deliberately use that behavior, just because it's super confusing to be like, oh, what's 5 plus true? Like, that doesn't make sense. Yep. So Boolean comes out of Boolean algebra. George Boole, famous mathematician of the Victorian era, who developed a whole system of algebra that's like logical algebra based on true and false values. That's why it's called a Boolean value, or abbreviated as Boole in a lot of cases. Yep. So all of these are Boolean operators. Comparison. Yeah.
There's more of it. Because we talk about Boolean operators
Yes.
in terms of and or and not.
Yep. So yeah, in programming in Python, you'll also see these. Yeah, as Kurt just said, and or not. These are all Boolean operators that an and is only true if both, x and y. That whole thing is only true if x and y are both true. But it's false if only one of them is true or if both of them are false. We'll probably get into that in a later
So there's
chapter.
some terms like those that light up as blue in Python because they're actually operators in Python.
Yep, things that light up in blue or a list of special words that Python has reserved. I'm gonna light them up in a special color. The Boolean operators are some of those words like and or not or whatever. So it means you can't have a variable that you call true, because Python's that's my word. You don't get to use that one. It has a special meaning. You can't use not. You probably can't use float either. But yeah, so the thing about data types is that this is where it gets kind of so different operations have different results depending on the data types. But when you combine data types, they tend to it's kind of this idea of they're making this reference to genes that there are ones that are dominant and there are ones that kind of are not dominant. So let's talk about division first. This gets important. So we were talking about floats, right? That they have their fractional numbers. And integers can't have fractions. So if you take an integer and divide by another integer, you'll get another integer. And so if you take 5 and you divide it by 2, the answer is not going to be 2.5 because 2.5 is a fraction. It'll just be 2. Yeah. Yep. So integer division. So this 1 divided by 5, that's going to wind up just being 0 because 1 divided by 5, I can't fit 5 into 1 any times. I can fit it into 5 one time or 0 times, but nothing in between. So this is going to wind up being, this integer division is going to be equal to 0. But you have this mixed case up here where you have this one, if you want to explicitly in Python call something a float, or use a floating point number, the easiest way to do it is just add a decimal point and a 0. So this is, okay, we're going to take this floating point number, 1.0, and divide it by 5. Even though 5 over here is an integer, because we've got a float on this side, our end result will be a float. Actually, this would also work if you did 1 divided by 5.0. So it's just, if this expression contains a float, it'll go ahead and kick you out of float. But if it, like, integer division has a rich history in programming, so like we're like, okay, we've got 2 integers and you want to divide them, we trust that you mean to be doing integer division.
So if you didn't use the point 4, then we stayed all in integer function unless we got into using the square root thing, which then, when you use the square root function, it introduces the float aspect and turns whatever your equation is then into a float number sequence rather than an integer number sequence.
Yep. So when you were doing the 4-4s, depending on which operations you use, you might have noticed that, or which numbers you used. Like if you used the 0.4, you might have noticed that some of your results were like wound up being 5, and then another one of your results might have been 7.0.
Right.
And that's kind of Python's way of being like, oh, well, the 5 was an integer, but the 7.0, that was a float number. Similarly, so with long numbers, Python will tell you whether that, oh, this is a long, by sticking a capital L after it. And so, like, a Google, 10 raised to the 100th power, a 10 with 100 zeros after it, or a 1 with 100 zeros after it. We can't, that's bigger than 2 billion, so we have to store that in a long. So Python automatically is like, oh, this is a huge number, stick it in a long. Let's go ahead and subtract a Google from a Google. That's 0. But since we're using longs, we wind up with 0, but it's still stored in a long. Yeah, you're going to get this result, 0L. Does that make sense?
Yeah.
Yeah, and so this is the slide I told you about where you're doing something that is just going to probably going to make you unhappy in the long run. Because you're going to come back to your code and be like, what sort of jerk went ahead and did 41 plus true? That's going to, but, so since we have an integer here, and we have a Boolean here, that's going to go ahead and be like, okay, well, true internally also resolves to 1, so 41 plus 1 is 42. True is 1, false is 0.
How do we know that?
Baked into language. It's like there's mathy reasons behind it of like just how we've like defined like the algebra around Boolean stuff. Again, don't rely on that. You could create like some sort of like Boolean statement that like if 1 or 0 or something instead of true or false when you want to use true or false. It's going to make the code like a lot harder to read. And like, I'm not actually sure whether or not true and false are actually, just because Python says 1 is true and 0 is false, Python may decide to change that. I'd be like, okay, we're just going to attribute 255 false. Because it's, that's 1 8-bit, it's a byte of just all ones. And we're gonna, so that's like all of them loaded, and then, or maybe that'll be false, and then all zeros will be true. So Python might be like, hey, we're going to do that, and their code would be. Yeah, if you search for like what it is, it's probably never going to come up. Your programming career, like, well, I would say personally, from a style point, you're probably doing something wrong if you're trying to add something to true, or add something to subtract something from false. Like, it's just like we're trying to do something real weird. So, yeah. So does that kind of make sense with the data types for everybody?
Mm-hmm.
Awesome. So sometimes there are a couple of more of them that you might, especially actually if you're doing anything with processing, or especially if you're doing things with Arduino. Sometimes these things are different sized. So like here in Python, our ints are 4 bytes wide, which gives us all the way up to 2 billion. In Arduino, they're 4 bytes. In Arduino, they're only 2 bytes wide. That only gets you up to like positive 32,000 and negative 32,000. Arduino, a long is what you need to get up to 2 billion. Just different sizes depending on the programming language and depending on the environment that you're filing to. But kind of specific, you will occasionally see a character, which will be a char, C-H-A-R. That'll be also known as a byte, and that'll just be 8 bits, and that'll be 0 to 255. That's something that you'll possibly run into, maybe even in this course. Those are just kind of like some specialty data types that you might run into. Basically, and also just know that this slide is Python. It's not necessarily like these sizes are not necessarily true for other languages. Like Arduino is like a board that you plug things into, and it's really good at reading in data from sensors and turning on LEDs and stuff.
How much do they cost?
Like $30. It's really popular in the arts community. So if you want to control lighting or if you want to control LEDs, Arduino's a way to do that. But yeah, this is also like I said, super low power computer that you're basic and it's only got 2 kilobytes in there of RAM and stuff. So, and that's one of the reasons why in Arduino land, because it doesn't have very much memory space to use, 4 bytes for every integer, it only uses 2 bytes for every integer. But kind of needlessly confusing. So just know that, the basic takeaway is that different types of data have different properties. One of the properties is going to be size, and the other main property is going to be whether or not you can remove division. It's going to give you fractional part, or if it's just going to give you back just an integer.
Python data. We wanted to do cell quantum.
Yeah, that might be a possibility. So, in addition to we kind of have this order of operations where if you're doing a float and an integer together, you get a float. If you're doing a long together with an integer, you probably get a long back. Similarly, we have in math class, we have operations and an order of operators. So this is the order of operations that you get. So equals. I shouldn't say equals, just single equals, the assignment operator, which we have a variable on this side and a number on this side. This occurs last. So if you have self equal or result equals 5 times 80, you wind up doing the 5 times 80 before that number gets stuck into that variable result. Otherwise, the order of operations is the same as the mathematical order of operations. In general, generally speaking, I tend to write code just using parentheses all the time, just to make it clear when math is happening and what order it's happening. Way to just make it clear for yourself that doing what you think you want it to be doing, as opposed to, oh, I mean to be doing subtraction first before I do this multiply, but like that's not happening right. Yeah, we'll go ahead and talk about modulo, because so we talked a little bit about integer division. Um, so, like, can your there we go. So whereas we had division with integers, that wound up giving us this kind of, okay, 5 divided by 2, that gets us 2, because we can only stick 2 5s or 2 2s into 5. We get 2 and then 4, and there's not enough room to get that last third 2. So, but because they're integers, we can't get 2.5. We just get 2. So what mod does is it gives us the remainder. So we got 2 2s in there, and we had 1 left over that we couldn't fit another 2 into, and so 5 mod 2 would wind us giving us. So yeah, like x mod y. So this percent sign is the modulo operator, generally called mod. So x mod y returns the remainder of when x is divided by y. Is that making sense to you guys at all?
So if the numbers were 5 mod 2, then the answer would be 1.
Yeah. Let me just a second. This is odd.
Are you allowed to use mod in the 4x4 thing?
I think so, actually. Let me double check. So I had muted you, Ilaria. See if you can unmute yourself. Just with the sirens going by, it was a little. Okay. Make sure that you can ask questions.
I'm not sure I'm understanding this. So 5 mod 2 would be 1?
Yeah, so it's kind of the idea that, so it, like similar to like long division. So so let's say so let's do like 11, or let's do, yeah, I guess let's do 11 mod 2. So if you're doing long division, that would break out to, put myself on the screen. So if you're doing long division, or whatever, yeah, I guess like this, where you have so 11 here, and then your 2 over here. So 11 goes into 10 5 times.
Mm-hmm.
You 10 down here, and then you wind up with a remainder of 1. So you have like 10 remainder of 1.
Yeah, but 5 mod 2, wouldn't it be like 2 with the remain of 1?
Yeah, and so modulo gets you that remainder.
Okay, sorry. I thought you guys said 5 mod 2 was 1.
Yeah, it is.
Okay, with the 11. Okay, I may have lost some audio, actually.
Oh,
Probably.
sure. So yeah, that's where kind of like division and modulo like work in to get like, so when you do a divide, you wind up getting that remainder, or that remainder from integer division is like the modulo.
Yeah. There was a misunderstanding. I thought it was 5 mod 2 equal 1, and I was like, no.
Right. Yeah, so I don't know if maybe talking more has just made it more confusing to you guys.
Because 5 mod 2 is 1, correct?
Yeah.
So 11 mod 3 would be 2.
Yeah. 11 mod 2 would be?
What would you?
That would be...
I mean, okay, interesting and curious little math thing to play with, but what would you use that for?
Question, what would you use that for? Modulo is my favorite. I like Modulo a lot. Let me pop this back up.
What division example will you
Let me see first, reach right.
The answer of the modulo is the remainder of the division.
Yep. So like that's basically how your computer like that won't destroy data. I mean it will if you want it to, but when it's doing the integer divide, it's like, oh, like, well, you divided 5 by 2, and you got 2. You know, there's some extra that you might want.
Okay, so like 100 divided by 33 is 1. Or no, mod 3. Mod 33 is 1.
Yep. It's 33 goes into 100 3 times, so, and then
remainder
there's
is
one, the remainder of 1.
So the mod only considered the remainder?
Yep.
Ah, that's what okay, I was not getting that.
Yeah, yeah. So, and this kind of brings us to Kurt's thing of like, okay, why the heck would you want? Why would you want to deal with a remainder? Seems
Whoever wants to deal with them.
right. So this is going to become super useful to you guys who are doing stuff with Arduino and especially with processing. So let's say you have a program that's running. So with processing, you have this like loop that's running, and it does all of your code once per frame. So it draws circles all over the screen and gets to the bottom of your code and like, okay, that's the frame, and we start it all over the next frame. If you want to, in processing, if you want to draw something every 5 frames or every 10 frames, you could set up a counter that's like, oh, how many, like, what frame are we on? 1, 2, 3, 4, 5, 6, 7. That can just go on, count number of frames since we started. And if you go, okay, what's our frame counter mod 5? Like when frame counter mod 5 equals 0, then that's every 5th frame. Is that making sense? So, where we start at, frame 1, and frame 1 mod 5 is 1. So we don't do this we don't do this extra task. And frame count is 2. 2 mod 5, 2. And frame count is 3. 3 mod 5 is 3. Frame count is 4. 4 mod 5 is 4. Frame count gets to 5. 5 mod 5 is 0. And so, do our special code. And then, next time frame count is 6. 6 mod 5 is 1. 7 mod 5 is 2. 8 mod 5 is 3. 9 mod 5 is 4. 10 mod 5 is 0. And so that lets us have these like recurring cycles by doing modulo that let us get like, okay, you're doing something through a loop. Like the most common way that I use this is you're doing something through a loop, but then every certain number of times you're doing that, you also want to do something else. And you just like compare it. You just set up a counter that's counting how many times you go through this loop, and then you set up this like conditional, this if your like loop counter modulo however many frames you want it to repeat for how many for how many frames. You set it like mod 5 or mod 10 or mod 30. So like if your processing sketch is operating at 30 frames a second and you want something to happen once every second, you can do it like, okay, if frame counter mod 30 equals to 0, do this, play this sound clip.
You were saying ones where the first number was smaller than the number after mod, like 2 mod 5?
Oh, it's like 5 mod 2. Oh, but like 2 mod 5?
Yeah, well, how would I...
So it's the same thing. So 2 divided by, 2 mod 5. Like 5 doesn't go into 2 any times. So 2 divided by 5 gives you 0. But you still have the remainder.
But it's 0. But if 5 is...
So the 2 divided 2 goes into 5 0 times with 2 left over.
So 2 mod 5 is 2?
Yep.
So what's 3 mod 5? So I can tell myself 3.
Three.
Give me a 7.
3 mod 5 is 3.
Oh, so it's always the first. So 4 mod 5 would be
No, it's the remainder. It doesn't go into it
It's
at
the
all.
remainder.
But, and then you have that number there.
But then,
that's the
so like
remainder.
5 mod 5 is 0, right?
So like it would be like 3 mod.
Mod 10 would be 3. 3 goes into 10 0 times.
4 mod.
Yeah.
It's a way to just
Yep.
get to that first.
Yeah.
Oh,
So yeah,
3
like,
mod 3 mod 10 is equal 3.
yeah, it should. There's also a good chance if you guys, you know, if you're like working on code and like, and again, use of the command of the Python interpreter would be to, let's pop that back over. Let me go over to hand. Screen share, check screen, share,
Ooh.
Oh,
Oh,
so here in Python, let's go ahead and 3
that was good.
mod 10. Hey, we got 3.
Oh,
That's a nice convenience. So if you
Pardon?
work,
a lot of light bulbs going on right now.
That's because 3 cannot contain 10. And then
yeah, exactly. So
So 31, put in 31, mod 10 would be 1.
yep. So feel free to open up a Python window and like try a bunch of different numbers and like try to
Can you
like
do mod with float?
try it. Let's find out. 31.0 mod 10. Hey, it gives you 1.0. So
What if you did like 31.4 mod?
question. I guess it technically gives you. This is a great example. So this technically gave you 1.4. So you guys are familiar with base 10, right? How we count. You use 10 numbers, 10 digits, 0 through 9. So computers operate in base 10. So number 0 is 0, number 1 is 1, number 2 is 1 0, number 3 is 1 1, number 4 is 1 0 0. That's binary versus decimal. I imagine probably that'll come up later. You'll see some things like hexadecimal. So anytime you see like a number that's like 0x 543E78, that's written in hexadecimal, which is base 16, which just winds up being convenient to use for various reasons. So a big thing about that is that it means that certain things that are evenly divisible in base 10 in our decimal system are not evenly divisible in base 2. So in this case, we have this like 0.4, and it winds up like Python does its math, and it's like, oh, I'm going to go ahead and do some weird odds and ends. Instead of getting 1.4 as like the result of, oh, we tried to, we fit three tens into 31.4 and then had 1.4 left over. It winds up, because things got transitioned, that this 0.4 got translated into base 10, or I mean base 2, the best it could do was, the most precise it could get was this 3.999999986. So something that you will run into is that you will get these like precision errors when working with even just like really like sensible looking floating point numbers. So floating points, like comparing, trying to compare for an exact match on a floating point number, you may not always hit it. So if we were like, oh, we want to, let's see if 31.4. What does that do when we divide by 10? Yeah, so if we divide by 10, since it's a floating point number, instead of 3.14, like we should get, we still get this floating point, like binary to decimal conversion error. So if you're going to be try to compare that to that should equal to 3.14, we're going to get false, because these numbers aren't actually the same. They're off by 0.0000003. Yeah, because their computer can't completely accurately deal with data. I think it does really well with like dividing things by 3 or something. But like it gets like, oh, like well that's I know that one. um, yeah, that's a thing. So we'll run into that. But yeah, I would encourage you guys to go mess around with the mod operator to kind of just make sure that like you know what you think you know what's doing, and it matches what you think it's doing. Sometimes I forget, like, oh, what exactly, like, I'll forget which order to put the things in. If I'm doing just like a straight up, like, 7 mod 3 or something. You're like, oh, is that 3? How many 3s fit into 7, or how many 7s fit into 3? Again, use the interpreter and kind of just, like, try out some different things and kind of get some practice, Miles. No, so I just hit, like, the Windows key. Like, Windows, PowerShell. Then if you have Python installed on your computer, you can type in Python and get that. Otherwise, in Cloud9, go on the bottom here, tab. There'll be one that's, the bash tab. I'd say bash. I'll see that thing right now. Yeah, this is usually says bash and gives you some stuff, but then you can type in Python and you'll get the live interpreter. All the mod 2. Hey. Yeah, so the equals operator. So this is the single equals. We've talked about this a couple times before. I guess in this course is calling the set operator. You'll hear it called the assignment operator very commonly. It is not equal to this test. Yeah, so you will, I guarantee, make this mistake like 100, 1,000 times in your programming career, bro. You'll do something, you'll have like if, age equals 5 when you mean double equals. The worst part is you won't get an error. It'll just be like, oh, that's cool. Assignment always equals true. Because like, oh, like, could I put 5 into this variable age? Yes, I could. And I did. And it was true. So, yeah, that's something that, it's a mistake that I've made many, many times. I've probably made many, many times. Just yeah, this kind of test your kid. But, yeah, so this is kind of, we're going to start talking about variables in a little bit. So, I've kind of mentioned this briefly before, but like variables are basically boxes for data. So we have these numbers, we have these words, these strings that we want to throw around. We can stick labels to them and use them later. So, should I print out this quiz and give you some time to work on it, or can you guys just like do it on paper here? How do you guys want to do this? Yeah. It's fine, 4 of us. Yeah. Let's go ahead and run through these lines. So I'll go in order with you guys and go let's each like take a line. So Ilaria, what does this first line x equals 41 do? What do you think it does?
Oh my god. I don't know.
Yeah. You guys have any ideas about what's going on in this first line?
It tells the program that x equals 41. So it defines x as 41.
Yep. So you have this. Yeah. We have this variable that we've named x, and we're taking 41 and we're gonna stick it into x. So what do you think this next line does? That's the thing a little bit. So X is 41. And these are just kind of text box to fill in answers. So like Jenny said, so y is going to be x plus 1, so 42. So what do you guys think z is going to be? Yeah. Yeah, so now we have these variables. What are x, y, and z going to be now? So we run through this, and so here's the current state. Then we run this fourth line, x is equal to x plus y.
Well, it depends on whether we're looping back through or what the values are that we're adding. You know, if it's taking current state of x, y, and z and doing a next operation to it or not. Specifics of the data.
So, yeah, I should have mentioned this before. So one of the important things about the assignment operator, single equals, is that everything on the right side happens to the left side. So this happens, and then it gets put into this. The assignment happens last. So in this line, what's happening is we have x is equal to 41. Write that in parentheses here. 41 plus y is 42. These get added together, and this gets moved into x. So even though x is 41 here on this side of it gets added to 42, and this whole block gets pushed into x. Yep. So something that's super important, y and z don't change. Like all we've done is change x here.
Right. The only operating line.
Yeah.
And it didn't tell us to go back to the top.
Yep. So something that like is a really common thing that'll trip people up is that they think, okay, y is now equal to like x plus 1 forever. Like y is defined as like in relation to x. Yeah, but it's actually no. We're running this calculation and storing this value into this variable called y. So this idea is like I always use this in boxes. So we have this like container with this box called x, and it stores a number, and that number started like okay, let's take 41. Let's take 41. Let's put it in this box called x. And okay, let's create this box called y, and let's take okay, what's the data inside x? Let's open up x, take the 41, add 1 to it, and stick it into y. We're just reading the value from x. We're not interacting with it, really. We're just like saying, okay, what's in x? So it's like a reference. It's like a name for the data. Then we're saying z. Okay, z is equal to like what's over here in variable x, and what's here in variable y. So that was 41 and 42. I add those together, that's an 83. That goes into z. Really, all this is seeing z is equal to 41 plus 42. This is really what the computer sees. Like, it doesn't it doesn't really care that x is a variable. It doesn't really care that y is a variable. It just is like, oh, you're telling me there's something in this box x. Oh, I found a 41. So I'm going to be equal to 41 plus, oh, there's a 42 in here. Equal to 42.
The original,
Uh-huh.
you're not multiplying 41.
Yeah, sorry, that's...
What is going badly over here?
Yeah, it's a little confusing. I should have done that on a separate line here.
Gotcha.
So this is the same as x equal to 41 plus 42. It doesn't like... Yeah, it doesn't see this as itself.
Why is it the editor?
That,
That's on the other side of
On the other side.
that's fine. Yeah. So it's saying, okay. And so remember when we were this order of operators slide? This assignment happens at the very last thing that happens. All the other operators take precedence. So what's happening here is that the computer sees this whole expression, says, oh, x equals to, oh, I do this last. I do this half of it last. So what's x plus y? That's 41 plus 42. That's 83. Okay, so this turns into x equals 83. It's basically like you were doing this. So since x plus y is equal to 83, now x gets assigned x x. Yeah.
Oh,
Yeah.
okay, that's why we all...
So yeah, well, one of the reasons that this is really confusing, and
Yeah, I know.
yeah, and yeah, and so this is also kind of a thing that they use just like these single letter variables. Yeah, just use single letter variables. Like exceptions for code. Like I'll probably like actually no. One of the things when you start coding is you use descriptive variable names. And so, like, since we don't have any context, like x equals 41, sure, but might be like, paycheck, or paycheck 1. Let's go to that.
No, he's saying do
Do
this.
this.
Do this.
Don't use X.
Don't use x and y.
Oh, okay.
Use variable names like they're free. You get to use as many characters as you want. So like use variable names
Tell it what it is.
yeah, they're just
Go back to the order of operations slide for a second.
yeah. It's got our order of operations.
Power.
Yeah.
You have to have a when you use that star, you have to have a number on the left. You have to have a number on the right. Then you need to multiply out the number on the left, the number of squaring on the right.
Yep. So it's like
If 3, you're cubing.
yeah. So it's like 2 to the 3rd power, or 2 to the 6th power. Oftentimes,
Okay.
this is actually this like asterisk asterisk is pretty uncommon. But most
Python thing.
yeah, it's a lot of other languages use the up caret. Like on US keyboards, it's shift 6. So it'd be like 2 to the 4th power, or 2 to the 3rd power. It's the up caret 3. It's kind of a Python thing. But yeah, that's the exponentiation or the power operator. Well, I think there might be a slide later in here that says one thing to notice is that it goes like ranked higher than the negation operator. So if you wanted to do like -2 to the 3rd power, this is actually going to do 2 to the 3rd power, and then be like, oh, negative of that. Instead of, but if you actually want to do -2 to the 3rd power, you need to just in parentheses like -2.
Oh.
It's probably not a situation you're going to run into a lot. I'll be honest.
Okay.
I'm not going to say that.
Uh, so yeah, we've got this little kind of extra over here that's just kind of like intentionally just like confusingly written. So let's do 11 and let's do A and B. So what's A going to equal? 11 divided by 2.
A is 5.
Yep.
Oh, yeah.
So again, this is the integer divide. 11 goes, or yeah, you can get 5 2's into 11. 11 divided by 2, you get 5.5 times, but we get rid of the 5. So let's see, what a 5. So what's B then? Yep. So C is like a total like question to script the nerds. If you write code like this, I will also yell at you because this is an order of operations thing that they're trying to be tricky by sneaking these spaces in here. Because this is actually going to be equal to 2 times r to the 5th. This is how it's actually going to work. Plus 2 times that. That's just the order of operations thing where even though it's like, oh, pluses right next together, since power takes precedence over addition, multiplication takes precedence over addition. You end up with b times a and b to the 8th power added together. Again, this is a great example of like parentheses of 3, use them. I mean, I've definitely run into it a bunch of times where I think I'm doing a certain math thing, but I'm just making a careless order of operations mistake. So, like, how you parentheses, like, oh, do this first, and like take this and then add this. But if I actually want 2 raised to the 5th power plus 2 times 5. Yeah. Oh, sorry, is that all making sense to you guys?
Mm-hmm.
Awesome. So this right here is probably quite possibly the most important thing in the entire class. Understanding how variables work. That like they're boxes and they don't defined by each other. So this isn't x is x or z doesn't change if x changes. Like if x changes after here, like down here, z, it's not going to change the value of z retroactively. But yeah, the way data actually works in the computer. I talked a little bit about this. And so it's like this metaphor of data as, or variables as boxes for data. It's actually more true than like just a metaphor. What's actually going on is that you have a memory location. So your program is doing all this like kind of black box computation, but data is actually getting stored in a physical location on a memory chip somewhere. And what your computer program knows is that it's got a name. Your variables have a name, they have a type, and they have a location in memory. And so like Python knows when you declare a variable, Python says, oh, well, I'm going to put you've got an int here. I'm going to put it somewhere in memory. So it handles where to stick it in memory, but it gives it a very specific, literal, physical place on your chip. So your memory chip, this is a very zoomed in view of one line of memory. So a bit is like crossover right here. It's a binary digit, on or off, 1 or 0. And a byte is made of integers. And there are billions of them in these memory chips that are in your computer right now. And your Python program like talks to the operating system when you create a variable, and the operating system says, "Okay, awesome. Like I will give you a tiny chunk of memory. Like so, an integer it takes up 4 bytes. It's going to get. I will give you 4 lines on this RAM chip that I will turn on and off to whatever values it needs to be in order to store this number." So like you have this actual like physical like bucket on your physical bucket that actually exists that has this value. They're all stacked up nice and neat, one after the other. So yeah, memory and RAM is just this big list of addresses for these buckets where you can store data. So yeah, kind of back to this slide. Equals operator goes ahead and names this data. It gives you a so if I go into like the Python interpreter again, if I just type in 41, probably that assigns it to memory somewhere. Like there's a 41, it just sticks it in memory, but we have no way of accessing it anymore. So like if I wanted to get that 41 back, like there's nothing I can do. I can't be like, hey, what was that number I just typed in? It's like, I don't know. That's kind of beyond. So the purpose of variables is to be able to, we have these numbers, we want to be able to use them later. So that's why we have these variables and that we. That making sense to you guys?
Mm-hmm.
So this is where things get a little bit more complicated. Numbers are obviously super useful, but sometimes we want to do more things than just store numbers. We have lists and strings. Strings are technically a type of list. In Python, we call them sequences sometimes. Yeah. So string functions. There's specific things you can do for strings. As we know, we put quote marks around them. That tells the computer that, oh hey, this is like text. It's not like this like 42 right here. In quotes is like a string. Like Python, like 42 plus 5. Like Python's not necessarily going to know what to do. Like okay, you just try it. It's like if you try to add 5 to tiger. Like I don't know. But say we want to add like my age is 42. Because sometimes it happens automatically. Like print will automatically tend to turn things into strings. But if we wanted to explicitly make a number into a string, we can use this str function. Converts whatever you stick it into a string. Similarly, we can get a number from certain strings, or certain numbers from strings. Like we can figure out how long a string is. With len function, it is the length of the string, and like an actual number. Similarly, we can add strings together. It's known as concatenate. Usually, most programming languages, it'll be like string plus string, and it'll just automatically mush them together. Sometimes it'll be called like string.cat for concatenate. This word might come up later in life at some point. If you're working with strings, you need to stick them together. Called concatenation.
But the XL and the IR, you would write that way.
Yep.
And you know that those quotes were that it's doing something different with those quotes when you're writing or yeah. So 4x4 is we would print and then we quote we put a quotient sentence.
Yeah. Well, I mean, these are just
treating it differently here.
just similar to portions of the sentence. This could be like rock. This is print to rock. Like I was kind of saying, this automatic string str. This turns it. If you have a string and you add a number to it, it'll automatically turn that number into a string. It'll automatically just be like a full string. It'd be like U42. That's what's happening with the print statement. Yeah, sometimes we can make them strings repeat. So we're gonna kind of skip this because I think I'll have some practice, like messing around with strings in the homework. All these making sense to you guys? So what is important is that strings are this type of list. So a list is just a collection that's like just a list of data. In this case, a string is this kind of special subset where it's a list of individual letters or characters. Space character, for instance, or that new line character we talked about. And if we have a string, like the string S, and if we want a specific character at a given point in it, we can say, like, what's the letter at position 2 on that string? That's known as the index, and we use these square braces to get that. Python also has these slicing operations, which I'm not going to talk that much about in the interest of time. These are very specific to Python. I'll go over them in the homework. I don't think they're that important to use. They're a way to get like a subset, a substring, or like a section of your data from a big list. But yeah, like that. So this, like variable name or list name, like the name of your list. So it can be a variable. So this is a variable S. It's holding a string, which is a list. Square brace, index, and square brace. You'll see that all the time. Super important. But yeah, so index in order to just get let's do a little bit of practice. So, well, something that's important to know, you may, depending on the screen, you got the numbers printed underneath all the letters in this. Indexes start at 0, so the very first character in your list is at index 0. So you start counting from 0, so 0, 1, 2, 3. So 0 is 8. What's 17 here?
G?
Yep. So 6. 6 here is the space character. It still exists. You'll get it, and it'll just be, quote, space, quote. Throw that in Cloud9. Let's do it. Space. Yeah, it'll probably show you the quotes because it'd be like, oh, this is a string. But yeah, that's just be a space bar. Something like, where would we find an E?
4?
Yep. Or we got one over here at 16 or at 18.
But how do I tell which one it is?
Doesn't matter for this one. This is an ambiguous question. Yeah, there are 3 E's, and we don't know which one this is. So for 16 or 18 would all work. All be a good answer. Python lets you do negative indices, which is kind of unique to Python. I'm sure it's done in some other languages, but
it drops off to 0 when it does that.
Oh yeah, it looks like it does drop off to 0. I'm going to kind of skip this slide. You might run into it in the homework. If it's not clear to you, skip it. It's something that I've never seen it. You don't see it in Java. You don't see it in C++. You don't see it. I've never seen it in another language other than Python. You're going backwards through your list. Like I don't know. Sometimes there are good reasons to do it.
So is that an error, or is that a question on the bottom?
Let's try it. So S equals. So one of the things with the interpreted thing is you can have variables. You can store them. We can go S, -0. No, I got SH, because -0 is just +0. Like that.
So then the,
Yeah, so it's just at index 0.
so on the PowerPoint slide, that's going to be
No, so it's going, so -19 is over here, -18, -17. So we count from the back, but 0 is still up here. So we can go.
Oh, okay.
So any number from -19 to +18 works. Just 0, since -0 and +0 are the same, it winds up being
Okay.
this H. We also run into, let's see what Python does. Let's see if we do 20. All right, we'll get string index out of range. This is an area that you will run into, I'm sure, or list index or whatever index out of range. It means that, okay, you said like, hey, what's the thing at the 20th position here? We only had 18 things, and so Python was like, I'm trying to access something that doesn't exist, so I'm going to give you an error because I shouldn't be. Yeah. So we can also do the slicing thing. We use this colon. This lets you get a substring, a little chunk of data. So like from 0 to 6, you can Harvey from 12 to 18, it's a colleague. So something that's important is that kind of in like in the range function or whatever, you get the 12th one, but you get everything up to this. You don't get the 18th, you only get to the 17th. So, and if you just leave it empty, you get the very end, till the very end. If you leave both sides empty, you get the full string. Yeah, this slide is just explaining it. The first index is the first character. The second index is like the number after the last character that you get. So, you know, if I did 0 to 11, I would only get up to this. I would not get this 11. We also have, these are kind of fun to try. I don't know if this gets you. 15 -1. What's that? It does.
I had so much trouble last week with it.
Awesome. Yeah, so one of the other things it does, this is like really confusing, or and like really pretty pointless, is that you can add a third thing onto it, which lets you like skip over things. It's what's known as the stride length. So like you start at 0 and you go to 8, and you pick every second one. You start at 0, you get H, and then you skip 1, and you get 2. So you're jumping, like incrementing by 2 every time. Similarly, you can increment by -1, go backwards. This would be useful on the homework. Just getting a substring and going negative, going backwards through it. Again, this is stuff that's very Python specific. So when you move to processing is like a special, it's like a flavor. It's a version of Java. Java with some built-in libraries. Arduino is C, C++. This stuff will not work in that. So that's why I'm kind of rushing over it. It'll be on the homework. It's kind of good as a way to like think about like moving through lists. But like outside of Python, you'll need to write your own code that'll be like, oh, okay, go to every second thing in this list or something. You won't just be able to go. And one of the big things about one of the reasons Python exists is to make kind of more common things like easier to do, like, hey, I want a string and I want to just get a certain chunk out of it, so I have this like quick notation to do that. That's why it's in Python, because it makes it easy. We start at 0, we get 0, and then we jump 2 spaces forward, we get 8R, we jump 2 spaces forward, we get E, then we get a space at position 6. And then since position 8, since we only get to 1 minus that, and the M, so we're at 6, and we jump 2, but then that's outside of the bounds. Making sense? The colon, so in this, with 3 of them, it's like the start index, the end index, and then the stride length. So it's a way of passing different variables or parameters into.
The 8 doesn't, as the end index, does not include a position of the string that you're on.
Yeah.
So in that range from 0 to 8, it only includes 0 through 7.
Yep. Yep.
That helps.
No. I don't understand why.
So in addition to, strings are like a type of list that we've been working through already. Lists can hold anything though. If we want to make a list, we have a bracket. Starts it, and then we separate each individual element in the list with commas. Lists in Python can store multiple types of data together. I'm happy to do that. So like in this case, we have a list with 4 elements. The first one is a floating point number, because we have the decimal point. The second element is actually another list. You can like put a list inside a list. Third number, or the third element in this list, is a string, and the fourth element is an integer. Is that making sense to you guys?
Mm-hmm.
So, yeah, and similar to like strings, we have this list.app. We have this len operator. This gets you the length of, but it'll only give you the number of elements. And so this is a list with 4 elements. Even though that this element is a list of its own, it only counts for 1 element in like how long this list is. It's like, because this is a list with 4 things. The first is a float, the second is a list, the third is a string, and the fourth is like, it doesn't care what's in each position. It just cares that like it's got 4 of them. Yeah, kind of same thing works with like the indexing, is the exact same. Same with slicing, we get a chunk out of this list. We don't even need to get the whole list. Yep. Yeah. So this right here, in the rest of the programming world, you will run into arrays a lot, and also lists. And so arrays are kind of like a special, like lower level version of lists. It can only be one type. So a list, or so an array has to only ever have like integers or floats or string. But this is the way that, like across, at least with C++ and Java and Python, this is how you access elements in an array or in a list. So this notation here, super common. You'll run into it whenever you see square brackets. 99.9% of the time, you don't even know if there's another case that isn't this. You're accessing data that's in some sort of a list or an array. Kind of like multi-parameter usage, like that's a little weird. That's a Python thing. That'd be getting a slice of this list like the same. So a more accurate thing would probably be L02. So L01 would be okay, starting at 1 or starting at 0 and ending at 1, so it'd still just be the 0 because we get like 1 minus this one. Like 02 would get the first 2 elements, which would be 3.14 and then this other list. Go ahead and the old Python interpreter. We did 02 to get this, the 0th element, and then the first element. Yeah, throw this into so much email. So we have L. So the interpreter now knows what L is. Let's grab L. So L0, this is 3.14. 0, 2, from 0 to 2. Yep, so it's got this first element, and then this second element in the array, which is itself another list. So, let's see. The nature of time, there are a bunch of kind of sample questions that I can skip over right for now. I just don't want to keep you guys too late. I just want to kind of preview functions that we'll be talking next time. Yeah. So we've got a bunch of, we've kind of talked about data and kind of storing it in like variable, and lists are this kind of compound data structure. It's a little bit of a, order to our, there's a little bit of structure to it. So we have this variable L that holds structured data. It's a variable that's holding, a list of data. So in addition to these like native types, so like 3.14 is a native float, like we can store a list of like these like core elements, core data elements. We also do stuff to them. To do that, we use functions. And so def is another special word in Python. It means define, short for define. Define might even work. There's def, so then we give it a name, and then give it some input variables, or so like an input variable, like a placeholder for when you actually use the function. Like this is like what it'll actually be operating on, and then it'll go ahead and spit back some sort of result. So like this function, dbl, put in a number, then it does this to it, multiplies it by 2, and returns the result of this operation. So double, so if you called, so if you were to do like dbl 2, that would wind up being 4. Is that making sense to you guys? This is just kind of a teaser anyways, but this is a way to, basically create things. Similarly, like we can, work on operations with strings, or any sort of, we could have this be a list. We could have this be any sort of type of data that we wanted. And so like there'll be a big chunk of working on your homework this week is going to be kind of starting to play around with functions. You guys have any interest in kind of going through more of the list operations? No.
Yeah.
I think I hit.
Yeah, no, that's totally fair. It's already 7:50 so over here, and super late for Laria, so call it a night. There are a bunch of answers on this in the lecture notes. I think you guys kind of already get it. I mean, it's definitely like practice stuff. Again, get on Cloud9, or if you've installed Python on your computer locally, mess around with just like trying different things and seeing, what makes sense to you in the interactive interpreter. I hope this has been useful. Like I said, this lesson and the next lesson on like data and functions are going to be like incredibly foundational to your understanding of computer science in general. If you have questions, please like pull me aside, talk to me after class, do whatever. Like understanding these things is gonna like probably the most important thing you can do as a computer scientist at this point.
Okay.
So yeah. That said, class is dismissed. Do you have any questions, Ilaria?
No, I think I'm too tired.
Sure. Awesome.
Today was a long day.
Yeah. Cool. Well, yeah, have a good one. If you guys have any questions, feel free to email me, give me a text, anything. Awesome. Bye.
Night.
Bye.
Bye, Sharon. Thank you.